Also. Okay. So good evening, everyone. It's with great pleasure and warmth I extend a heartfelt welcome to all of you present here. We are truly delighted to have each and every one of you with us today. This initiative of IAPT to organize the lecture series on physics education research is aimed at advancing the field of physics education in India. We are honored to have experts in the field of physics education research as our distinguished speakers for the series. Today is the 8th lecture of this series, and we are honored to have with us the esteemed president of IAPT, Professor P.K. Ahluwalia, who will be the speaker of today's event. The topic of his talk is the role of IAPT in quality physics education and spreading physics pedagogy and PER practices. I'm glad to welcome Professor P.C. Deshmukhji. He will be chairing today's session. So before we start, I just want to introduce Professor Deshmukh also. Professor Deshmukh was a professor in IIT Madras from 1984 to 2016. During a period of 2009 to 10, he was also appointed on deputation as Professor of Physics and Dean of Academics at IIT Mandi. In 2016, Professor Deshmukh joined IIT Tirupati. Since 2020, he has served as an adjunct professor of physics at multiple universities and as a mentor and convener for Center of Atomic, Molecular and Optical Sciences and Technologies. He has made many contributions to physics education, including publishing foundation textbooks in classical and quantum physics, and his lectures are freely available to all of us through NPTEL. So welcome, sir. We are glad to have you with us today. And I would also like to extend a warm welcome to Secretary of IAPT, Ma'am Rekha Ghodpade. And for further proceedings, I hand over the mic to Professor Deshmukh. Sir.
Thank you. Thank you very much, Seema ji, Sapna ji. I'm very grateful to you for giving me this opportunity to be with the IAPT meeting this evening on physics education research. It is an extremely important area because means pushing the frontiers of physics requires teaching students who will then change the face of physics. So this is an important area, and we are very proud that our association, Indian Association of Physics Teachers, has undertaken this seminar series on physics education research. And we have one of the best speakers we can have on this topic today. So it's a great pleasure, great honor to have with us Professor Ahluwalia ji. He is, of course, our president. He is our very own person and needs absolutely no introduction to this audience. But I would like to reflect on a few points which are very inspiring when you follow Professor Ahluwalia ji's career. It is great to have him as the president of IAPT and leading our efforts. But it is also very inspiring to reflect on his career. And we all know that he has been with the Himachal Pradesh University. He has also contributed to the Inter-University Accelerator Center in a big way, teaching over there various applications, computer applications in physics and whatnot. I will not go through all of his achievements, which are outstanding and remarkable, mostly because they will be known to almost everybody, but highlight just one or two features. He's, in my mind, a great physicist. Means foremost of everything else, he is a very respected physicist who has made very rich contributions to condensed matter physics, dilute magnetic alloys, low-dimensional electron gas, quantum dots, and these frontier areas of condensed matter physics, computational material science. He has also been a mentor. He has supervised many PhD theses. I think some 18 or 19 students have completed their PhD under his supervision. Also, a large number of MPhil projects he has guided. He has written a few books, computational physics and related areas. And he has led computational applications, established high performance computer facility uh, for large scale calculations, including density functional theory applications. He has spearheaded similar efforts in many organizations, not just at the Himachal Pradesh University. He has a large number of publications. He's a very often, his works are cited in some of the leading papers in this field. And that's something that we are all really very proud of, Professor Luwaliaji, to have you amidst us. Of immediate relevance to today's evening is his commitment to provide leadership in physics education, science popularization. He has also undertaken radio feature writing, developed spoken tutorials, very novel contributions to physics education. So it's a matter of great privilege for all of us. Means to have Professor Ahluwalia address this seminar series today evening. He has developed resources for statistical mechanics courses, and he has also, provided leadership to the community. He established the University Institute of Information Technology, led FIST projects and so on. So his leadership is outstanding in many areas of research, teaching, popularizing science. And of course, one thing that I enjoy very much are his very nice drawings. He's a great artist. So wonderful to welcome you, Professor Ahluwalia. Let me not come between you and the audience.
Thank you very much. I'm so glad that you have been able to spare time for us, and thank you for your kind introduction. Thank you, Sabna, for hosting it. And I am sure that we will have wonderful time today. I also thank the members who have joined us in this particular event, because this event, I feel, is not an ordinary event, in the sense that we are in fact completing this month on 31st December, 40 years of the establishment of IAPT. And this is, to my mind, a great, great achievement of the community who stood by IAPT and made sure that things proceed to the possible, reaches where it should reach and leave its impact. In that sense, I would say that I am very fortunate that I am in a position to serve IAPT community in a position as an office bearer, which really puts a lot of responsibility, because I know that the leaders who led this organization were committed personalities like Professor D.P. Khandelwal, Professor Babulal Saraf, Professor Hans, Professor Vakmare, Professor Vark, also Professor Vijay Singh, Professor H.C. Pradhan. I think I have many role models before me whom I find I can really follow. And that itself is a great advantage with which I am actually uh, serving and working to the cause of physics education. Now, as far as uh, this presentation is concerned, Sapna, please allow me to share the screen. Please enable the screen sharing. Are you the host?
Sorry, sir. 1 minute, sir. I think, sir, try now.
Yeah, I can do that now. Fine. Are you able to see my presentation?
It's coming actually. We can't see it just now, but it yeah, now we can see it.
Okay, fine. Thank you.
Yeah, you can go full screen.
Yeah, I will go. Yes. Just for a minute. It sometimes takes time. Is it full screen now?
No, not yet.
Okay. I think it will happen. Okay, all right. In the meantime, I will try to do it. Maybe there is some small issue in refreshing the screen. So the title of my talk is Role of IAPT in Quality Physics Education and Physics, Pedagogy, and PER Practices.
Yeah, we can see it.
Yeah, I have divided my talk into different parts. First, I will describe how I see 40 years of IAPT. Then I will try to come off what are the roles of subject societies in spreading quality education. And then I will come to what is the role of IAPT in this direction and how it can help in spreading physics pedagogy and PER practices.
It's a meeting.
So let me just describe very briefly
That is
40
not
years
important.
of IAPT's journey.
My existence in the meeting is important.
Sharmishta ji, can you please mute your microphone? Sharmishta ji? Yes. Yeah, please mute your microphone, Sharmishta ji.
Mute. Yeah, please mute.
Yeah, good.
Okay, so let me begin this 40 years of IAPT's journey. In fact, it has been a team effort which was initiated by like-minded people led by Professor D.P. Khandelwal. And I think at that time, in 1984, to think about such an organization was like providing a dream to the physics community and a vision to the physics community. And what Professor D.P. Khandelwal did single-handedly was that he brought eminent teachers, faces, physics educationists on one platform, schools, colleges, and universities. And if you look at the set of people who were there, you will find that they were very, very dedicated souls for the cause of physics and physics education. And the best part of it was that his sweep was so large that he didn't really think of, say, forming a organization of university researchers and teachers, or maybe extending that to college teachers. He wanted to work at the grassroots level. So he brought in school teachers, college faculty members, and university faculty on one stage. And his aim was to reach every corner of the country through regional councils. I think this was a great way of organizing IAPT. And he thought of publishing from day one a bulletin of Indian Association of Physics Teachers. And all the time, if you look at some earlier volumes of Bulletin of IAPT, you will find that he has been a votary of conducting workshops, telling teachers to come together with, say, small, low-cost equipments to create stage shows for physics. He initiated right from the first year an annual convention of the Indian Association of Physics Teachers. We recently had 37th IAPT convention. And also, as it progressed, very many people actually brought in new ideas also to it. For example, one of the ideas was to start Prayas, a student research journal, which was, again, a very ambitious program. And right from the day one, he was actually interacting with people in Kanpur, in Pune, and in Mumbai. He was in touch with Homi Bhabha Center for Science Education. He was in touch with Professor Babulal Saraf, who was working on physics education and development of equipments. He was in touch with people who were actually bringing out physics education from Pune University. And now it is being handled by IISER Pune. There have been a bit of ups and downs in the later publications, but Bulletin has kept its promise and it is published very regularly these days without any kind of a difficulty. Now, if you look at other engagements in which IAPT came forward in a very big way, that was engaging itself in the conduct of national standard examinations for, in the beginning, physics only, but later in chemistry and biology for selecting teams for Indian Science Olympiads and International Science Olympiads, like International Physics Olympiad, International Biology Olympiad, International Chemistry Olympiad, and try to see his generosity. He was very, open that if we are doing something, it is not just for physics people. It is also open for other science people also. And I think his influence was the reason that the Indian Association of Chemistry Teachers were initiated and Indian Association of Biology Teachers was also initiated. Conducting this program for almost 25 years now is a very big task. It requires huge voluntary effort. It requires a lot of logistics which go into it, right from thinking of when it will be held during the year, and then pre and post conduct parts of this big examination, plus, generating very useful data in the form of question papers, question bank, and providing a peep into the status of physics education. And through that, knowing that what are the possible interventions which can be made. The performance of this program has been very, very satisfying, I would say. And that is the reason that now we find that it has become one of the most prestigious set of examinations for physics, chemistry, and biology, and also for junior science Olympiad. It has given, a lot of opportunity for the physics community to come together and participate in various steps for conducting this examination. So this is a very, very big achievement, I would say, IAPT really got while he was thinking about this IAPT as an organization. I remember that there was a program which was also initiated in the name of National Graduate Examination in Physics later, which was a kind of an offshoot of National Standard Examination. And again, it has become a very prestigious examination in the country. And students who actually sit for this examination also get directly admission in some, say, centers or institutes for doing their research work directly by getting them into the system.
ভারতের যে স্বাধীনতার ইতিহাস না সেই ওই শ্যাম বাহাদুর মানে একজন সেনাবাহিনীর কমান্ডার
Sanjay Pal sir, please mute yourself. So this is one thing. Now today we have digital documentation of all the bulletins which have been published till date. Also, we have a very good network called National Anveshika Network of India, NANI, which was initiated by Professor Aran Kapoor as Anveshika, and later it was taken to a much higher level in the form of NANI by Professor S.C. Verma. And this year I had an opportunity to visit the Sopana Ashram of Professor S.C. Verma, where I saw that how a kind of a team has been created to carry forward this very interesting work. And lately, they have also started bringing out a newsletter called Anveshika Buzz, which primarily focuses on science experiments in schools up to secondary stage. So this is a very interesting involvement of the school teachers via this network. And in Himachal Pradesh, I know that this network has floated an idea of starting satellite networks also. Also, NANI actually conducts a very comprehensive test of experiments for the students of schools, colleges, and universities. And it is very interesting to note that similar same experiments are given at these three levels. And the outcomes which then happen are very interesting to actually study that how things operate in schools, colleges, and universities. And I think this is one of the most crucial areas in which our schools and colleges and universities are lacking as far as conducting labs is concerned. We also have many programs which try to be in touch with our members, and through them a large community of physics stakeholders, both online and offline, and also in hybrid mode. I think this is a program which is being conducted in offline mode, but we are open to conducting programs in both online and offline mode itself. It depends upon the kind of opportunities which are available in different institutions and how they take it. Also, the huge data which is being generated by National Standard Examination is available with the Chief Coordinator of Examinations. Presently, Professor Tyagi is the Chief Coordinator. And let me also underline here that Chief Coordinator of Examinations is a very, very challenging job. And we are very fortunate that it was held first by Professor Dharkar, who really made it very stable. Then by Professor Venkatesh, G. Venkatesh. Unfortunately, we lost him this year. We had met him in convention, but I don't know. Sometimes we have no control over these things. But he also contributed significantly and brought in information technology into the system. Also, this data which is available with us, it is waiting to be analyzed by using the tools of physics education research, like question item analysis, creating concept inventories, and maybe using machine learning and artificial intelligence for looking at what this data actually is telling us as far as quality of physics education is concerned. I was recently in Homi Bhabha Center for Science Education in Mumbai, and that was actually the celebration of Golden Jubilee of HBCSC. We were able to meet the community who is committed to physics education research in that symposium. We had a wonderful presentation by Professor Arvind Kumar, who was director of HBCSC during its formative years. And what is his view on the status of physics pedagogy and physics education research? By the way, this was also a celebration of his 80th birthday. So I think this is an area which is open to us, on which we should really think of working. Now, thanks to COVID, I think I should not use this term, but sometimes, there are certain things which become blessings in disguise. In the last 3 years, we have seen a spurt of activities of IAPT because of the availability of wonderful IT tools for content creation, content delivery, assessment, question banking, and so on. And I'm very happy to tell you that now we are getting used to it also. I remember number of programs which have been conducted, and these programs are very, very important programs which are of interest to us. I know recently we had a program in Bangalore where Professor Deshmukh conducted a hybrid program, particularly on the Nobel Prize, which has been given for the year 1923, which is once again a very fascinating topic on which this has been done. So we are thankful that such things are happening. There were some workshops also which regional councils actually conducted as a joint effort. I know that Mumbai RC, sub-RC, and Bengaluru sub-RC, they conducted a very interesting workshop on computational physics itself. Professor Sharmishta Sahu and Professor Shetty were two leaders in that direction. And very good thing in that program was this, that their students also helped in conducting that program, particularly in the sessions where the participants were supposed to write programs, etc. As a result of this, what we find is that IAPT can really generate a lot of resources in e-formats. And I would like to tell the honorable participants here that this has started in the centenary celebration year of Professor Babulal Saraf and Professor H.S. Hans. During the convention, one of the volumes on experiments in physics was reprinted and launched with the help of Professor Shishodia, who was one of the co-writers of that particular book with Professor Babulal Saraf and many other people. It was a very good community effort, once again, I would say. And Professor Babulal Saraf was dedicatedly working for improving the quality of experiments in physics education. And he was also one of the presidents in the formative years of the IAPT itself. So this journey is on. This milestone of 40 years provides us an opportunity to look back and prepare a vision for the next 10 years to make IAPT an impactful platform for engagement by all possible means with its stakeholders. And I think this is one of the tasks which we would like to perform in the next 3-4 months. We would like to really have a document in which we can always define some milestones to achieve in the next 10 years so that it doesn't remain an organization of physics teachers at national level only, but it should acquire an international status also. We have also started taking steps to generate conversations across various regional councils through our own Zoom Meet software. And we also have, from 1923, started giving some incentives to members and regional councils so that they come forward with their agenda, which they want to really carry forward with the stakeholders. And we gave this year in the convention prizes also for that. Ma'am, can you please mute your mic? Ma'am, can you please mute your mic? Okay, fine. So I think we are ready to now go ahead and talk about the second part of this lecture. Let me try to see what is the role of a subject society, because such subject societies are everywhere. And if I try to see the constitution of our subject society, that is on physics, we find that one of the very prominent agenda in these subject societies is subject pedagogy and subject education research. And lately, this has been taking a center stage because of the coming of national education policy. Also, the role of subject society is to keep an eye on latest innovations and curricular changes happening in the subject nationally and internationally and identify their implications. Now, implementation of national education policy is a kind of a game changer which is happening in the country. It's not a small thing which is happening. And the kind of documents which are emerging, I think in the past, it was never like that. At every step, I think we are finding implementation which is taking place is bringing new challenges to the policymakers, to the subject societies, to the board of studies, and also to think about resources, that how such a big agenda can be implemented. This is a very important part of whole of this. So as a result of this, I think subject societies have a very important role, and that is carrying out surveys among the stakeholders, students, teachers, researchers, to know their perception in a scientific way about various concerns. I think this is a very important part. And I am very happy to say that under the leadership of Professor Samanta, IAPT has conducted a nationwide survey on status of school labs in the country. And a very comprehensive report was also prepared by them, which was published in the IAPT bulletin. and it was circulated among the people who are responsible for taking decisions like directors of education, etc., etc., in various states. Also, our members have been working very closely with the uh, diets for schools. They are also very much part of human resource development centers in the country of the UGC. They are also very much part of certain very important documents which are needed for implementing all these things. Like, for example, syllabus drafting itself. I know that ever since in our country we started talking about reforms, uh, there has been a lot of talk about that what kind of syllabi we should have, and are we going to have a uniform for all the people like in a school, or there is a possibility of having diverse things as menu which can be offered to the students. So subject society provides a platform for dialogue, brainstorming, and awareness about what is happening as a result of this National Education Policy 2020. And I think we have started doing that. We have done well. And mm, as a subject society, we are fully aware about this. Uh, it's very important that in this context, subject society should always be looking for the various policy documents which get generated. For example, in the context of schools and undergraduate studies and postgraduate studies, today we have documents which are like national curriculum frameworks for different levels: schools, undergraduate studies, and PG studies. And also we have national qualification frameworks which provides the kind of attributes which our graduates should have when they pass out from their colleges and the universities itself. So this is another very important kind of a task which subject societies have got. Also, I think it is very important, and if you look at the subject societies all across the world, you will find subject societies like American Association of Physics Teachers, uh, um, this IUP, they are very much active in all these areas. They create position papers to identify the learning gaps, prepare model documents such as syllabi, textbooks, lab manuals. If you go to IUP's website, you will find that they have started creating textbooks also. They have started creating lab manuals also. Very, very imaginative kind of things actually they are doing. And lately, the impact of national education policy is visible in the sense that in states, people have started talking about learning outcomes in a very, very big way. Only yesterday, there was a news item in Indian Express from Himachal Pradesh, where a directorate of education has given a task to the schools that in the first 15 days of the next academic session, when it starts in the month of April, they should spend time on identifying the learning gaps among students and look for ways and means how the students who are lagging behind can be helped. Now, I think this is an outcome of that thinking which is really getting generated as part of the implementation of national education policy. Also, subject societies need to conduct workshops both online and offline to be in touch with students, teachers, peer groups, subject experts, researchers, institutional managements, etc., who have the onerous task of implementing changes at the ground zero. So this document, which you are seeing here on the screen, is a document which was submitted to NCERT and CBSE and Ministry of Education as a document which actually brought out concerns of physics community in the country as far as school level physics education is concerned at the secondary stage. So this is, I think, a very interesting document. And we are one of those subject societies which took this step to move forward. Now, I wish to talk about a few things which are now happening in the country and which are raising lots of concerns also. One of these is the introduction of choice-based credit system. And, sometimes we feel that is it something new? And the answer to this question is that it is a very well-established system. Even in our country, if you look at the apex institutions of learning in the country, like IIT, IIMs, NITs, and so on. Particularly in technical education, we have been talking about credits. It was only in 2009 the University Grants Commission started writing letters to the vice chancellors of the universities to go ahead with choice-based credit system. Unfortunately, at that time, they had not provided any kind of a scaffolding for introducing it. The real momentum came in this direction when Rashtriya Uchchatar Shiksha Abhiyan was launched, and higher educational institutions particularly started getting grants under RUSA. This has, in fact, two basic purposes. One was to improve the quality of education in higher educational institutions. And second was introduction of choice-based credit system. Now, it was only after National Education Policy came that UGC brought out curriculum and credit framework document for undergraduate programs. Before that, there was nothing. Universities were free, whatever they wanted to do, though UGC was threatening that if you will not implement it, we are not going to give you what we call the grants from the UGC itself. So that was the stage. And this started happening in 2013. And I fortunately was in a position in the university where I could see that how this can be done with lots of challenges. And those challenges have not gone away even now. This curriculum and credit framework, this is available on the UGC website. In fact, I shared it in our V in IAPT group also. And National Education Policy implementation has many lessons to learn based on what happened in RUSA. In fact, there is a change in name in this now. It is being called Prime Minister's USHA, whereas RUSA and USHA, they are one and the same thing. The agenda is examination reforms. And I think after COVID, there has been a lot of emphasis on creation of online courses and raising the quality of infrastructure and focus on a kind of a flagship program being generated out of the online courses itself. There is an agenda in implementation of NEP that students studying in higher education institutions should do part of their or earn part of their credits by participating in what you call these online programs being developed by NPTEL, for example. Now, this is again very, very important part. Now, this National Higher Education Qualification Framework is again a very challenging kind of a work which has been done. There are lots of feedbacks coming about it also. But one of the things which it brings is bringing Indian higher education at par with the global qualification frameworks, which is again another challenge. As far as engineering was concerned, our degree was 4 years. So students going out of the country were able to get admissions very easily. But undergraduate students after 3 years were supposed to, they used to find it very difficult to get admission for master's programs outside the country itself. I think that kind of a gap is also being bridged in this particular program. So what is changing on the ground zero? We are finding that there is a shift to semester system. We are finding that introduction of choice-based credit system is happening. But the situation is, in whatever way you really see it, you are trying to introduce that in that fashion.
लोकेश ये आधार कार्ड है ना, डॉक्यूमेंट टाइप्स हो गया आधार कार्ड.
Dr. Juhi,
Juhi.
please mute your microphone. Dr. Juhi.
Yeah. So there is a lot of concern about the introduction of choice-based credit system. RUSA offered many interesting, ways to look at it. For example, when we were talking of choices, maybe undergraduate colleges cannot offer those choices. So they thought of bringing in a concept of cluster universities within a range of about 20 kilometers around a lead college. Now, in some states, it is working. In some states, these cluster universities have been converted into state universities, and its spirit has been killed. Now, impact of choices and choice-based credit system has a lot of impact on subjects like physics. And there is a lot of confusion prevailing as a result of choosing major courses and minor courses and prerequisites for a course like physics. Now, we are saying that if you choose physics as a major, everyone sitting here will agree with this fact that you need to have mathematics with physics. And it may not be, possible to have a course within physics which just exposes students to mathematics required for physics. But a broader, look at mathematics is desirable if one wants to study. So can we have, say, in this situation, a kind of a bonding of such courses which are prerequisites for, say, doing a particular course? This is another very important point. There is a lot of confusion among teachers and students about undergraduate degree with research and its impact on enrollment in PG courses. Our friends in Karnataka, where it is being implemented, are telling that suddenly we are finding that numbers are coming down in physics courses. In fact, it is at a stage where some college managements, undergraduate college managements, are thinking of, say, closing down the physics departments itself. I think this is a very, very worrying situation on which we have to really look very carefully, because you cannot really let a subject like physics struggle for having good students. And this can also lead to loss of jobs among teachers, particularly at undergraduate level, and its cascading effect on the PG courses in the universities also. Research-based component to earn honors in a course through 1-year PG program is also very challenging. And sometimes people are thinking that will this close doors for past course students? Though national education policy says that if people are coming for doing their masters after 4 years, they will have to spend only 1 year, whereas those who pass out after 3 years, they will have to do a 2-year degree. But when we actually try to go to major and minor distinction, if anybody who comes with minor in physics, sometimes what people are doing is the people who are drafting syllabi in the universities, the course quality for the pass course students is not at par with what is expected for them to go ahead in the master's courses. So this is also one of the challenges. Another very important challenge at which I think we must really think very carefully is that if we want this choice-based credit system to be of some quality, you cannot really run this as part of affiliating system. One reason is that if you have very large choices which you offer to the students, it is very difficult to even draft a date sheet under the affiliating system because you have to satisfy everybody. Once you make it autonomous and make people responsible for having their own syllabi, having their own examinations, etc., I think it is possible to manage it carefully, provided on autonomous system, a kind of a regulation regime should be there so that the quality is not suffering. This is again a very, very important part of this. So as I was telling, this is going to have an impact on not only physics, physics is one example, on STEM faculty. So implementation of NEP is gripping the STEM faculty, that because number of students are decreasing, they are not choosing STEM subjects, so which will be in fact detrimental to the availability of even STEM manpower for critically emerging areas which require a thorough grounding in sciences. And I think physics is one of such areas which has always brought a paradigm shift in how we look at the phenomena in nature and how they impact society itself. Even if you go back to the development of computers, etc., you will find that it was nothing but something which came out of physics itself. Manhattan Project required computers, and they tried to really do simulations for their nuclear program. And this is how, you know, the development of computers for scientific computation also happened. And I am sorry to say that physics is the major sufferer, and a stage has reached where higher education institutions are on the verge of closing basic science departments, particularly in private higher education institutions. It has its own repercussions on employment scenario of teachers, but will lead to a dearth of human resource, as I said earlier, for future as well. And I think it's like the story of blind men which is operating in the country. Please don't mind my words. We must really remember that the ground reality is very different, and each blind man had his own picture very far from reality. So we have to be alert what is being required. The change doesn't need to be regimental, but it needs to be logical, keeping in focus both quality of education, need of the subject being taught, and progression of the students without pain. So this dilemma of major versus minor, I feel, is the biggest concern. Why I am saying this? I am saying this because of one very important reason. NEP actually offers students an opportunity in majoring in more than one subjects also. And it doesn't abandon students who pass out as pass course students, as I slightly mentioned earlier. So there is a element of equivalence of the course content offered as minor and majors, say in physics. To convert a minor into second major, there must be an overlap of the courses between major and minor of a subject for a smooth transition and not mere transfer of credits of minor to go for major course. And the content of minor courses should not be of a subsidiary nature and lower quality under the excuse that it is catering to non-major students. These are also catering to the students who wish to major in a minor course. And this requires a thorough look into the courses offered as minor subjects and major subjects. I think subject society is actually very nicely placed to look at these kinds of impacts which are happening. So what is the role of IAPT? This is the last part of presentation. The role of IAPT in this context is to bring electricity in the formulation of the courses in physics, to make students of physics ready for latest windows of opportunities, for employability, pursue subject for higher studies. And we need to design courses which are to be drafted with these layers in mind, which cannot be separated by rigid boundaries. I think this is a task which has been cut for us with a lot of responsibility. While making a submission to NCERT and CBSE, IAPT came forward with a well thought out and drafted document with possible alternatives to a situation where we were hearing in the name of load shedding, the syllabus is being cut. Therefore, we cannot remain complacent and must work immediately before things go out of our hands. It is our responsibility to rise to this particular occasion. Lately, I am very happy to tell, IAPT has been part of an outreach program at IIT Tirupati, where a hybrid seminar has been organized on disruptive science and technology. I think this is becoming talk of the 21st century. Thanks to Professor P.C. Deshmukh that we were also made part of that. And this seminar brought together theoreticians, experimentalists, and industry people who underlined the need for bringing curricular changes in tune with the needs of the industry and design UG courses to meet the demand of trained manpower requiring good grounding in physics. I remember in one of the seminars, I asked one question to one of the industry person who was talking about quantum technologies. That what do you think how physics students can participate in these things? And he said, yes, physics students can participate in these things with some kind of very thought-provoking things which need to be introduced at the undergraduate level, particularly introducing, say, quantum mechanics through matrix approach, which is the way it is being introduced in quantum computer field itself. So these are few things which we must really look at, and this can come only when we start talking. And this seminar actually provided that kind of a opportunity. Unfortunately, these seminars, these lecture series, seminar series is available on the YouTube. This can once again physics as a major course in demand, provided we bring those components into the curriculum. We must watch and take care of what is happening at the interfaces of disciplines and not shy away from handshake. I think this is again a very, very important part. And with the spread of our members at various forums, I think we can catalyze this kind of an opportunity among stakeholders. Quantum technologies, quantum computers, machine learning, artificial intelligence, medical physics, material science, and computational physics are some of the areas where such opportunities lie. And people are saying that physics courses at undergraduate level have ample opportunities of bringing these elements into the way we deliver content to the students itself. I think we must really look at this aspect carefully. And for this, IAPT needs to be proactive so that it becomes a hub of designing and offering courses in the online mode or hybrid mode as part of resource generation effort. To gauge the situation, as a first step, IAPT intends to circulate online validated questionnaires on different aspects of the syllabi itself. Yeah, please don't worry about it. So as I was telling you, that it has to become a hub of designing and offering courses in the online mode and hybrid mode. To gauge the situation as a first step, IAPT intends to circulate online validated questionnaires on different dimensions impacting science education in general and physics education in particular. There is urgent need of discussions and exchange of ideas to investigate this situation. And as I told you in the last about 2 years of my interaction with the members of IAPT community, I have come across huge talent waiting to do their bit. And I think IAPT doesn't lack that. And that makes me very hopeful. Changing with the times is the clarion call, but with caution and speed. We as subject society need to create opportunities for both learners and teachers and encourage research-based studies both in pedagogy and in PER. I would like to tell you that when I thought of giving this lecture a title particularly focused on physics pedagogy and physics education research. Uh, in the symposia which I participated in HPCSC, I met very many interesting, and committed uh, professors of eminence who were of the view that there is one thing to teach something as part of a syllabus or a course content, but organizations like IAPT can really encourage through different possibilities a what you call in-depth learning of the subject itself. I had one talk with Professor M. Sivakumar from Hyderabad University. When we were discussing, he was trying to underline one fact. He was trying to say that, is it possible that we start talking about quantum mechanics not as a subject being introduced, but letting people feel hows and whys of quantum mechanics, not as part of the syllabus, but maybe a kind of a supplementary thing which IAPT should roll out. I think these are the possible approaches which we can uh, look forward to. Also, I remember that there is one very interesting survey which has been done internationally, and that is known as force concept inventory. This inventory is available to us in English, and one can really download it, and there is a complete algorithm by which it needs to be, say, uh, given to the students as post and pre activity, uh, and try to see that what are the learning gaps in understanding, say, the laws of motion itself. IAPT has been looking at it lately, and we thought that giving it in English will mean that it will be available only to those students who are studying physics in English. But what about students who are studying these courses in vernacular languages? And I'm very happy to tell you that the first effort in translating this inventory has happened by immediate past President Professor Vijay Singh. It has been translated into Hindi, and it is available for implementing in the schools and colleges also. I think it is good for both the places, particularly for first year students in the college. Also, it has been translated in Bangla. There was a team of RC15 who really worked on it. Professor Chinmay Ghosh and Professor Panchadhyay, they were part of this, and that is also ready and it is available now. There was an effort made in Punjab also to translate it into Punjabi, and now we have requested our honorable members in Gujarat, Maharashtra, Tamil Nadu, and in Karnataka to really make an effort to translate it. And IAPT can really take charge of implementing this survey throughout the country and see where we stand as compared to where the international students stand. So when I'm talking about physics education research, these are the surveys which have been designed using uh, physics education research, but there are other elements also which involve pedagogy in fact. Like, for example, if I wish to present a particular topic to students, there can be more than one ways and maybe one particular way of presenting that particular topic to the students, maybe very, very imaginative to make students understand these things. So some kind of an interest needs to be, brought into that among the IAPT members itself. And that is how I see the role of it. And let me just share with you the values which Professor D.P. Khandelwal inculcated among IAPT members. Science as service to society, society above self, scientific temper, spirit of inquiry, reaching out, volunteerism, teamwork, team building, networking among institutions at all levels, empathy towards students, mentor-mentee relationship, passion for lab work, and use it as a cradle of talent. For this talk, which I have shared with you, I got an opportunity to read very many documents as part of study with members from IAPT itself, and I think we need to really look at these more carefully so that we are able to bring those kinds of agendas on the table of physics teaching and learning, which are very, very relevant for the 21st century. Finally, I would say that we have reached a stage where we should start thinking about what at IAPT, when it has reached a milestone of its existence for 40 years. And I believe that we need to really think about physics, think about innovation in physics, think about those things which are so relevant for the learning of physics and contributing to the progress of the country and of the society itself. We have a very dedicated, dynamic website available now. We can reach out to our members through emails immediately. I hope you are receiving those emails, etc. also. And I wish that when we go for our Golden Jubilee, that is IAPT at 50, we should have something to show on the ground as a result of the activities of IAPT. Thank you very much for your kind attention, and please do visit our website, which is the official website of IAPT, www.indapt.org.in. Once again, I thank you all, and I am now open for the questions which you would like to ask me. So I'm back here.
Wonderful talk, Professor Ahluwalia ji. Very visionary talk. You have woken us up to changes which are taking place. These are very rapid, and to prepare ourselves for the future is going to be a big challenge. So I'm sure there will be several questions. Let me open up the forum to questions.
They can write in the chat also if they feel
Yes.
like. Yeah.
Yes. Or you can unmute yourself and ask, or you can write in the chat box.
You can raise your hand. You know that there is reactions also. You can go there and you can raise your hand. Yes.
Yes, Professor Bhupati ji.
Good evening. I was listening to this wonderful talk by Professor Ahluwalia. Now, frankly, since I'm retired, I'm really not having this experience of classroom teaching for last 10 years or so. So I'm really not very sure whether I'm qualified to raise this issue. Still, what I gather from my friends and colleagues, I'd like to share that with you. That is, that has already been mentioned by Professor Ahluwalia, that there is dearth of students, lack of students in physics. He has talked about the private institutions, but so far I know, more or less similar scenario is prevailing in most of the colleges, undergraduate colleges. Of course, if we leave aside the central government funded, very prestigious institutions, as he has mentioned, like ICERs, IITs, and some others. Now, the question is, physics is getting more and more difficult, and what you have observed, I personally like to mention that as download syndrome, the people go on pushing the things downwards that, well, since we cannot, we have to teach so many other things in the master's degree, let this go to the undergraduate, and undergraduate people push this down to +2 level, etc. My humble submission is that what is the feeling of, I mean, not only of Professor Ahluwalia, this, because of this august body, those who are listening, happily listening to this excellent talk, what is the feeling? Because so far, I mean, do we appreciate that as a crisis? That physics in one way is getting difficult. On the other hand, we are not getting good students. So if we go on talking about the different systems, different modes, how far will they be effective? This is what is my humble submission. I mean, I'd like to listen what people feel over here.
You want to listen from me or from the audience which is sitting there?
I mean, anybody can reply because, you know, since I'm not teaching, as I mentioned, for last 10 years, I'm curious to know really.
Yeah, I think Professor Ahluwalia is the most qualified person to respond to
Actually,
this.
let me share a few things which I didn't mention in the talk. During 2013, I was Dean Planning and Teachers Matter in my university. And the government started talking about RUSA. And in fact, government approached university that now RUSA is coming, lots of grants are going to be there, but there is a rider on that we must go ahead with reforms in the higher education institutions. And one of the agendas was introducing choice-based credit system itself. Now, there was nothing as a what you call blueprint available with the UGC that how we should go about it. So we tried to really look at what is the meaning of choice-based system and credit system and grading system also with it. So when we tried to draft our, structure, kind of a scaffolding on choice-based credit system itself, we found that if we are talking of introducing choices, when we will introduce this system in our university, our educational institutions like colleges, etc., will have no window for choices. What they will do is, they will say that this is available to us. We cannot offer you any choices. Whether you want to take it or not, it is up to you. So one suggestion which was given was this, that when you actually offer your courses, actually make a timetable in which you show that what is possible and what is not possible, what people can take as majors and what people can take as minors. Another thing which was there was that we were not in a position to really have different courses for major and minor. So there was an overlap in the sense that if you are majoring in physics and if you have as a minor course opted as chemistry, the chemistry course was such that if you want to go for your MSc program, you should not feel that you are not able to go in MSc with the minor course itself. This was it. Another was drafting the syllabus itself. Normally, let me tell you that how do we draft syllabi in universities? Normally, the chairman of the PG program is asked that please draft a syllabus, bring board of studies members there, and over a couple of days they sit down and then they decide, okay, let us do it. But that time we did an experiment, which is very interesting and important. We said that we are not going to do it at the board of studies level. First, we will do it at the level of the teachers itself. So for Shalini, please mute it. Shalini, okay, yeah. So let me come back. So what we did was we said we will have a 3-tier system in which
There seems to be a little bit of disconnect.
Yeah. I think he has lost the connection, internet connection.
we will have a seminar
Okay,
and look
yeah.
at that
He's
syllabus
back.
more carefully.
Yeah, Professor Ahluwalia, can you just go back for a minute or so because we lost the connection with you. So I
Okay.
request you to repeat the last point that you made.
Am I audible now?
Yes, you are. Yes.
Fine. So what I was telling was that when we were to draft the syllabi, we did it in 3 steps. First was forming a a group of teachers, giving in the task of drafting the syllabi. So that was kind of a core group. After that, we said, take it to a group of 40 teachers of the same subject so that they can have a look at that syllabus in the form of a workshop and make recommendations and finalize at that level the syllabi. And then it was supposed to go to the Board of Studies. Now, what happened as a result of this was that when this was introduced, the teachers and the colleges were owning that syllabus. That was the first thing which happened. Whereas what happens now from UGC is that the syllabus is coming from top and is to be followed. They say you can at the most make changes of 10 or 15% only. I think this approach is not the kind of approach which is needed in our country. So these are the issues, which you need to take into consideration. And if you start, matching major and minor courses contents at some level, you will find that that dearth of students may also go away. This is very important part which we need to understand. Now, when this is being implemented, let me tell you what is happening in Uttar Pradesh. In Uttar Pradesh, what they said was, for first 2 years in undergraduate, common courses will be given to the students. And it is only in the final stage that when we start talking about major coming into picture, those courses which will lead to the research degree kind of a thing. In Madhya Pradesh also, there is a different kind of a, what you call design coming. So are we diluting the kind of thing envisaged in the national education policy, or we are going ahead with that? There is a big question mark on that. And that is what should be an agenda for discussion itself. So this is what I had to say about Professor Bhupati's remarks. So I hope I have been able to address some points which he raised.
I understand there are, multiple issues, and really we cannot handle everything in a single go. Thank you. Thank you very much.
Thank you.
Is there any other question?
Professor Chinmay has raised his hand. I've seen it.
Yeah. Professor Chinmay, please. Professor Chinmay, are you there?
And sir, there is a request in a chat box for your reference. They want to see the reference slide.
Yeah.
That's it.
There is one remark which has come in the chat box. I'll just read it, which is from Dr. K.G. Bhole from Mumbai. Professor Bhole is actually secretary of the Mumbai sub-RC. It is on remote sensing, geophysics, geomagnetism can be additional courses. You talked about translation of some inventory on PR, public pedagogy in Marathi. Can you elaborate it? In fact, we have requested Ma'am Rekha to go ahead with that, and I hope she has found somebody to do that task. Yes, Professor Chinmay, please.
I'm sorry, there was some technical problem. In fact, first my compliments for an excellent presentation. You have given multiple dimensions to the issue, and as Dr. Bhupati Chakraborty mentioned, that all those things cannot be handled in a single session like this. I am raising an issue regarding the role of IAPT. And as has been mentioned by our stalwarts like late Professor Khandelwal or Professor Subhash Samanta, and even the entire team of IAPT members have been conducting several workshops with the teachers and students, mostly with the teachers, so that it has a cascading effect on the students. Now, what we find that at the end of these workshops, the teachers feel quite enriched. But when we ask them about the follow-up action at their respective institutions, well, the responses we receive are not that encouraging. Whether IAPT can have a role to monitor the follow-up at their parent institutions, because if it ends with a workshop, we did an exercise to have back to back 3-4 workshops at an institution, and it had a better effect than the normal kind of workshops we do. I know it is easier said than done, but if some suggestions emerge how we can engage ourselves in such a direction. That was my question. Several other questions appearing
Yes.
in my mind, which we'll keep discussing.
Yes, in fact, you have raised a very, very important issue, I would say, not a question. And that is that IAPT can, start very many initiatives in the sense. One initiative which can be very interesting is to even think of some kind of a model things. For example, model labs, model theory courses, model what you call courses at the interfaces of the subjects itself, which can be brought into physics. Rather, they can be very interesting as elective subjects for people other than physics also. Now, why I would say that IAPT is the best choice for doing these things? Because we have, members from all over the country. So if we wish to have any kind of, agenda or this kind of a work, we can get feedback from variety of members. Now, we are also, very nicely placed with regional councils in various regions itself. So I would love that if we start with a core team who can really identify what are the tasks which we should really take to the regional councils to work upon and collate those to bring out what you can call as the model documents. I think that will be one way of going ahead with it. Second thing is this, when I was talking about the National Higher Education Qualification Framework, they have started talking about the attributes of the student when he or she comes out from the university. Now, we need to really look at those attributes also and try to see what are the attributes which we can really give as a physics student when he goes in the market itself. There is a generalization of attributes, and those attributes cannot be generalized. For example, when you look at the physics students, you will find that they are very good in problem solving skills. Even IT companies have started realizing that they should not only offer, placements for what you call engineering students, they should come to the science departments also to look at the students who can do wonderful things as far as problem solving is concerned. So I think we need to look at that in a very coherent manner so that we can really see that IAPT brings out something on the table to look at compared with what is happening at the national level itself. Because we have our own viewpoint. And there is no other way to bring that viewpoint on the table unless we work hard on those documents. I feel that that is one way of going ahead with it. Now, second part is physics pedagogy and physics education research. I think up till now, what is happening is that different people have different ways of doing the things. For example, in the lab, I think that way IAPT, as far as its resources are concerned about lab, they are very much there, but they are not visible to the people if they want to really adopt those. What can we do for adoption of those kinds of things on the ground is another agenda which we should really look at. I know that there are certain courses for which there is no design available. For example, at undergraduate level, if I want to introduce quantum computers, is there a content available to us? If we want to introduce, say, medical physics for physics students, is there a content available or not? If we want to introduce something corresponding to the new technologies which are likely to be there in future, Are we ready for those things or not? Can we really design something for that? And this is precisely where, many subject societies outside the country is actually indulging in. And I think we must really look at that. American Physical Society is known for all that. Lately, some of our members attended some symposia of American Association of Physics Teachers. Y.K. Vijay was there. Professor Meenakshi Syal was there. So there are certain things which need to be done in our country, and we cannot really say that we conduct a symposium and forget about the rest of the year. No, it has to be a continuous process throughout the year by taking into confidence our regional councils in that particular direction. I think this is the only way to go ahead. And Professor Ghosh, you must be definitely enjoying this fact that for working on our submission to NCERT, we didn't find it necessary to meet together at one place and talk. The technology is such that we can really do all these tasks sitting at our homes without wasting time in traveling from one place to another, and still come out with very interesting solutions. So I think we should really take our steps without worrying about whether anybody is going to read those documents or not. If you do something, definitely people will see these things. I remember, I'll tell you from Himachal Pradesh University my experience. When we drafted our syllabi and posted those on our website in 2013, after that, UGC started an exercise for drafting the syllabi at undergraduate level. And many of the courses which we drafted, those are adopted by the UGC syllabus itself. I had a presentation of about 3 sessions on choice-based credit system. This was downloaded throughout the country. So if we do something, it will get noticed. Website is a wonderful place where whatever we do, we can really offer to the people. We can be open enough for those things. Thank you.
Thank you.
Any other question which is coming to your mind?
There are one or two comments and questions in the chat box. So we will take those, and then I think we will encourage other questions by email or something.
Okay.
Sir, I have a humble submission. I'll have to attend one more meeting. Should I be allowed to leave, sir?
Oh, yes, please.
Thank you.
Thank you, Professor Bhupati ji. Thank you.
No,
Dr. Bhole observes, he comments on the remote sensing, geophysics, geomagnetism, if these can be introduced as additional courses in the context of translation of some inventory on PR pedagogy. And he will like you to elaborate on this.
I think, yes, this menu of choices can definitely be extended to these. There are certain places where we can definitely think of looking at the model syllabi for these subjects at undergraduate level itself. I think this is a kind of a list of papers which we can really create, rather curate, I would say, and then start drafting the syllabi for those. There are 2 more comments which I would like to really read.
Yes.
One is from Juhi Mishra.
Yes.
She is asking, how can I, as a high school physics teacher, get started with physics education research? Could you provide some leads? Juhi, are you a member of IAPT?
Yes, sir, I am. Good
So
evening,
if you visit our website, you will find that there is one drop-down menu called Web Links. You please go there. There you will find that we have curated a host of websites from where you can find a lot of resource material for physics education research itself. I would very strongly recommend you go there and try to, look at the things which are available there. One leading journal in physics education research is brought out by Physical Review, which is known as Physical Review Physics Education Research. It is open source. So the papers which are there, you can download. And there are very many leads which you can take from there and which can be tailored specifically to our needs. They require a lot of, tailoring. It is not that you just take those and try to implement those things here. But those are very interesting, websites where you can go.
Sir, I wanted to know, so how does it work? Do I carry out research with my students in my classes and then put up my research paper, or is it the other way around?
It is actually converting your classroom into a research lab. Okay, and it is definitely done with the consent of the students itself whenever you want to do anything. For example, some areas I talked about this force concept inventory, right? This is nothing but a set of multiple choice questions. But it is not just that I draft these multiple choice questions and give it to the students. In between, that methodology of physics education research comes, which wants you to do a certain number of steps before your set of questions is ready for implementation. And then there are studies to see whether this inventory of questions, when you give, what kind of preparation you have given to the students. Did you do some kind of a study before and then after introduction of the topics and the implementation of the survey? What is the difference? So it becomes a kind of an elaborate exercise, and it is very scientific. So it is not that you randomly go and do certain things. Okay.
Got it, sir. Thank you so much for your response.
Yeah,
Sir.
there's
Yes.
one more query from Ankita Sengupta.
Yeah, Ankita, are you there? I am a mathematics teacher from West Bengal working for 14 years. My experience says it is very difficult to teach according to the training we get. Actually, at present time, there is no encouragement to learn new teaching techniques and to apply them practically in classroom. How can IAPT help me to enrich myself? Ankita, are you a member of IAPT? Please respond.
Please unmute yourself, Ankita.
Ankita, unmute yourself. Okay. Let me tell you, Ankita, one thing.
Yeah, she says yes. She has replied in the chat box. She says yes.
Right. Yes, Ankita, I hope you are finding and you are receiving our bulletin also. Be in touch with us. Let me tell you how I got into looking at physics education research. I was going through some of the papers published in on a very interesting website, archive.org. There is a section of physics education research papers which are published there, posted there. And I came across a paper which was entitled, What Economics Education Teachers Can Learn from Physics Education Researchers. That alerted me, and I thought that there is something very interesting which physics education research people are doing. Why not go into it? Why not look at that? I read that paper and found that this is a very, very, area, very interesting area in which physics education or subject education people actually work. But there is a question mark here, and that is this. Is this kind of research needed to be done in physics departments or mathematics departments or in education departments, so-called education departments, which are there in every university? And physics education researchers very strongly believe that if you have to do research in this area, then you have to do it in the physics department or in the mathematics department or in the chemistry department. You cannot really ask somebody sitting in education department to do it all alone. You can collaborate with them to look at what are the methodologies which they follow, but physics has to take center stage. Mathematics has to take center stage, or chemistry has to take center stage if you want to do chemistry education research, mathematics education research or physics education research. So I would say that, and there are a number of very interesting strategies which are available, like, flipping the classroom is there now. There is this clicker method is there, teaching large classes, with students numbering about 200. And I think our country has reached that kind of a situation where number of students in the classes is very, very large at the school level or the
Yes.
undergraduate level itself. So this is how I look at it. I hope it has answered your question.
Sir, just I wanted to say that, can you hear me?
Yes,
Yes,
go
what?
ahead.
Yes, I just wanted to say that it's about 14 years and I'm always trying to teach mathematics in various ways. But today the situation is now in our state or maybe the whole in India that everything is mathematics is totally a subject of just about to the score, just have the pass mark. Uh, there is no importance is given to the base of mathematics, or you have to study mathematics because mathematics, after all, the mother of sciences, and it is for analytical thinking. So the total situation is now that just give marks, the pass marks, only teach those item, and this is very and this it is very usual way we have got training that you do the teaching in various ways, low cost no cost material use it, but ultimately when we go to the classroom or the students are very supportive, but there are very pressure coming that why are you doing all this, so this is not done, no, don't do this, no, yeah. So I just wanted as a IAPT, can you give, can I, IPTA can give me some regional persons or someone whom I can contact to enlarge my experiences and my enrichment. How can IPT help me in that? I just want to share my experiences and enrich it so that
Okay.
I can work my.
Yeah, Ankita, you have raised a very interesting point, that when you talk to your colleagues and then they say, why are you doing all these things? I think
Yes.
as a teacher, you should not worry about those things. I mean, they will keep on saying that because sometimes people are not tuned to, taking initiatives in their area.
Yeah.
But let me say one thing, that as a teacher, you are queen in your classroom. Okay.
Okay.
Your students
Okay.
are a dedicated audience which is available to you.
Yes,
And
they
if
are.
you think that
Of course.
something which you are doing is definitely helping them, you should continue with that. Don't worry about that
Okay.
kind of a thing. Second
Okay.
thing,
Okay.
whether you can really get in touch with anybody in IAPT, let me tell you, RC 15, Regional Council 15, is the most active regional council of IAPT itself. Professor Bhupati
Okay.
Chakravarti, you listen to, no?
Yes, actually, he said me to have membership in IAPT.
Then Professor Chinmay Ghosh you talked about. Professor
Okay.
Samanta's name you have heard about. Professor
Okay.
Panchadhyay, they are the people who are
Huh.
leaders, who are
Okay.
helping, who are
Okay.
masters in reaching out.
Okay. Okay.
You please get in touch with them. I'm very
Thank
happy
you.
that you
Thank
asked
you.
this question, and I think that they are
Okay.
going to help you. Thank
Thank
you,
you, sir.
Ankita, for
Thank you
your
very much.
question.
Thank you
Okay.
very much.
Okay, thanks.
Hello, sir.
Yes. So I think if there are any further questions, I suggest that you send an email to Professor Ahluwalia ji. This has been a very fascinating evening, Professor Ahluwalia ji. We are very grateful to you for this.
Thank
Very
you.
visionary talk, I must say. And you have opened up a large number of very basic questions in front of us as physics teachers. Perhaps you might be able to constitute as president of the IAPT a few committees which will specifically look into some of these questions and come up with a white paper to move forward. There are rapid changes, not just the new education policy, but also artificial intelligence and new things which are happening in education and research. We are very grateful to you for such a stimulating talk.
Yes, sir.
Over to you, Professor Sapna ji.
Yes, sir. So you are absolutely right, sir. It was such a wonderful talk, Professor Ahluwalia. Thank you so much for sparing your time and enlightening us with such a wonderful talk. So I'm very thankful to Professor Deshmukh also for chairing this session. And all the participants, I'm thankful to you for listening very, very patiently and asking beautiful questions. So with this, we come to the end of this session. Thank you, everyone.
Thank you, Sapna, and thank you,
sir.
Professor Deshmukh and the participants.
Thank you.
Thank you very much,
Thank
everybody.
you, sir. Thank you.
Very many thanks to everybody. Thank you, Sapna, for conducting the session so beautifully.
Thank you, sir.
Thank you very much.
Thank you, sir. Thank you, everybody.
Okay. Goodbye.